Hello everyone, my name is Vyoko Saravia. My brand name is Lotensin. Its generic name is Benazipro and the chemical name is C24H29ClN2O5. As you can see here, it tells you what the drug is used for, when you should not take the drug, significant interaction with other drugs, and something interesting about the drug. So this drug is used to treat high blood pressure. You should not take this drug if you have had a angioedema, significant interactions with other drugs, and aliskin. Something interesting about the drug, it can cause a stroke. Okay, so now I'm going to show you how to draw the skeletal structure of my drug. And that is how you draw the skeletal structure of Lotensin Benazipro. So for the next page, it's the expanded structural formula. And here you go. This is the full expanded structural formula for the drug Lotensin. So for this page now, we are on the theory molecular geometry predictions. Instead of putting color-coded, I put numbers to indicate the geometry around central atoms. And in the bottom, it shows you what number 1 is, what number 2 is, what number 3 is, number 4, number 5, number 6, and number 7. So now this is the molecular formula and molar mass calculations. Molecular mass of this compound can be calculated from the sum of molar mass of individual components. I did 12.01 times 24 plus 1.008 times 28 plus 14 times 2 plus 16 times 5, and I got 288.24, and then I added 28.224 plus 28 plus 28, and I got 424.46 grams. Hydrogen bonding with water. Instead of using red lines, I did purple lines because I did not have a red pen. So hydrogen bonding is a special type of dipole attraction between molecules, not a covalent bond to a hydrogen atom. It results from the attraction force between a hydrogen atom covalently bonded to a very electronegative atom such as nitrogen, oxygen, or a fluorine atom. This shows the extent of the H bonding in Lotensin. So now this is the hydrogen bonding with water structure of my molecule. All the polar bonds participate in hydrogen bonding with water. Oxygen and nitrogen atoms of the drug molecule containing lone pair or electrons, and they act as if they're the donor in hydrogen bonding. Here's hydrogen and oxygen, oxygen, hydrogen, hydrogen, oxygen, and so on. So this is my polarity and solubility prediction. As you can see, I circled all the polar groups, and as the molecule contains a sufficient number of polar groups, after all this, we can predict that this molecule will have sufficient water solubility. A report also says that this molecule is water soluble about 100 milligrams over milliliters. Solutions calculation. Now, to make 50 milliliters of 2.30 times 10 to the negative third M solution, certain numbers of moles need to be added and mixed in 50 milliliters of water to make a new solution. And that is how I found the number of moles. So for number 2, it says calculate how many milligrams of the drug are contained in 2.0 milliliters of a 3.0%. So this is what I did. I substitute 3.0 to find mass in grams of the drug dissolved in 100 milliliters of water. And this is how I got the grams of the drugs.